In topic 9.5, we're focused on climate change. And climate change is an expansive topic. We can talk about lots of different effects on ecosystems, effects on humans and society. There's entire college courses and even majors that are related to climate change. So what we talk about in this topic, will be sort of a preview of larger issues that you may study someday, hopefully. So when we're talking about climate change, we know that the climate on Earth has changed significantly over the history of the Earth. And we can collect data on carbon dioxide levels and on temperature in a whole variety of ways. We can go well beyond, human temperature records. We can gather data from ice cores. When you drill down into ice that has been on the Earth for a very long time, you could sample from that ice little air bubbles that are trapped, and that can give you information about what the atmosphere was like at that time, what the temperature was like. We can compare isotopes of CO2 to help us understand the historic carbon dioxide levels. So there's a lot of science that can go into actually trying to determine what the Earth's prior climate and atmosphere was like. So if we look at what that data tells us, we can see some information here. So this graph on top shows over the last 500 million years the average global temperature in degrees Fahrenheit. And what we see, so here's where we are today, and we can see that it's varied significantly over time. 500 million years ago, the average temperature on Earth was above 90 degrees Fahrenheit, whereas today it's somewhere around 60 degrees Fahrenheit. And so there has been a large fluctuation. This graph actually shows the temperature of like around 68 or so, 67. When the global average temperature is above that, that's an Earth without polar ice caps. When it's below that, there are polar ice caps at the North and South Pole that can just give us sort of an idea about what these changes in temperature mean. So we can see that data here. We can also see that data in this graph on the bottom, which gives a lot more detail. So again, it's broken up into different time periods. And this x-axis scale, it changes from era to era, epoch to epoch. So we can see that here. This is a short time period up to 1,000 years ago, and then we start going millions of years. But what we can see is the same sort of information. We could see fluctuating climates. Okay, you can see periods of time when it was much colder, periods of time when it was, much warmer, much colder, and so. When we look back at the last period of time here, okay, these are thousands of years before present, what we see is that this little blip we see at the end, or the blip we see here, shows us that the climate has changed significantly. These are projections for future climate in recent history, and we'll be talking about that. We've already talked about why that is, and it's the burning of fossil fuels that really began around the time of the Industrial Revolution. And we'll talk in this topic about what impact that has on ecosystems, on humans as well. And so as the Earth warms, we know that the global average temperature of the Earth is warming. And as the Earth warms, there are significant changes that happen in the oceans. One of those is that sea level is rising, and there's two main reasons for that. One is as glaciers, which are ice sheets that are on top of solid land, as those glaciers melt, those ice caps and ice sheets, that water eventually drains into the oceans, adding to the volume of water in the ocean. But also, a really big factor is thermal expansion, that as we heat up the Earth's oceans due to climate change, they expand. Water expands as it gets warmer. And that expansion in the volume of water in the oceans is also an important factor related to sea level rise. And as sea level rises, that has impacts on aquatic ecosystems, on marine ecosystems. because a rising sea level changes the depth of the ocean. It floods coastal areas, and that alters ecosystems. When a terrestrial ecosystem gets flooded by these rising ocean waters, it changes a terrestrial ecosystem into a shallow intertidal zone in those areas. And obviously, organisms that were adapted to that terrestrial ecosystem are no longer able to utilize that ecosystem as their habitat, and either have to move to other areas or may become extinct. It also changes as the depth of the ocean changes. As ocean levels rise, it changes the zones that in the depth of the ocean. The photic zone is a zone that has light penetrating into it, and so that changes as ocean level rises. Okay, the mid zones in the ocean, they change. They can become deeper, and then you have the deep ocean areas. And so organisms are all adapted to living in certain conditions, and as those conditions change, again, that could impact the biodiversity of those habitats. The ocean also changes in terms of ocean currents. We talked about ocean currents back when we were talking about the basic earth science in the first two units of APES. And so we know that there are these ocean currents. It's called thermohaline circulation, that are large-scale movements of water throughout all of the Earth's oceans. Sometimes this is called the ocean conveyor belt, because it is conveying heat energy generally from the tropics toward the poles and bringing cold water back towards the tropics. And so we can see some diagrams that show this thermohaline circulation. And that word thermohaline means it's related to temperature, and also haline means a salinity. So these ocean currents are driven by differences in the salinity of the water, how much salt there is, and the temperature of the water. And these thermohaline circulation circulates heat around the Earth and has major impacts on the Earth's climate. And so as the climate changes, as ice caps at the poles melt, that meltwater is fresh water. And as it runs off into the oceans, it dilutes the salinity of those areas. That makes it less salty and therefore less dense, and that changes these convection currents within the ocean because they're partially driven by the salinity of the water. And so as that salinity changes due to the melting of the water, it could result in the breakdown or the alteration of this ocean conveyor belt. Winds also change related to climate change. And so the winds generated by the atmosphere, we talked again earlier in the unit about the science between atmospheric circulation. We talked about these convection currents, these large-scale convection currents that are present in the Earth, where we had rising warm air at the equator, and then the sinking of that air around 30 degrees north and south. But as the Earth's warming, those convection currents are changing. The tropics, that they are migrating towards the poles and expanding the area where those convection currents change. And when that happens, that results in changes to ecosystems. We know that the major biomes of the Earth are largely dictated by these by these convection currents that are present in the Earth's atmosphere. And the winds that are generated by these convection currents in the atmosphere also are changing. Okay? And one example of that is in the jet stream. So when we look at the jet stream under normal circumstances, the jet stream is air current, an upper air current that circulates around the northern parts of North America and Asia as well. There's also a polar vortex that rotates as well, creating winds. And as climate changes, the Arctic air around the poles is warming faster than other latitudes. And what happens in those cases is that the polar vortex and the jet stream weaken and become less stable. And what we see is this sort of meandering jet stream, where instead of sort of being at consistent latitude, it varies from time to time. It varies spatially as well. And what we can see is that could be times when it brings polar air deep down into North America in this example, or sometimes warmer air from the mid-latitudes migrates up towards some of these more northern latitudes. It makes the climate less consistent and less predictable. And this is one of the reasons why we might have winters where it's very cold. Even though the overall global average temperature is increasing due to climate change, it still means we might have times when it's cold because of this weakening of the jet stream. It's also why sometimes we've adapted the terminology we use, where we used to refer a lot to global warming, and that term is still used, but the Earth's climate is much more complex, and so talking about climate change really is a more accurate way to describe how humans are changing the Earth's climate. Our soils are also connected closely to climate, that as the Earth warms, as changes happen to the climate, as precipitation changes, that can affect the soil as well. And it can affect it in several different ways. As climate changes, as carbon dioxide levels increase and temperature increases, what happens is that can increase decomposition in the soils. Okay? Because as we warm the Earth, decomposition happens more quickly. This is especially true in cold latitudes, where cold temperatures generally limit the rate of decomposition. As those ecosystems warm, there's more decomposition, soil carbon breaks down, releasing carbon dioxide into the atmosphere, leading to higher atmospheric carbon dioxide levels, leading to more warming and more decomposition. It creates this positive feedback loop of self-reinforcing phenomenon that can be very dangerous in terms of accelerating warming. Climate affects soil fertility, the amount of water required for agriculture. It can increase droughts. It can increase heavy rainstorms. There's all sorts of complex factors that are important to consider as we think about how climate change will affect things like agricultural production. Another example of a positive feedback loop, and again, when we talk about positive feedback loops, we're not talking about positive as in helpful or useful. We're talking about a feedback loop that's self-reinforcing, that accelerates itself. And another example of that is called the ice albedo effect. As I said previously, the poles are warming quicker than other parts of the Earth. And so as that happens, the poles are covered in ice generally. And so as the poles warm, that ice melts. But ice reflects the majority of incoming solar radiation, maybe around 90% or so is reflected and only 10% is absorbed. But as this ice melts and turns into open water absorbs much more of that incoming solar radiation, up to 94%. And so as ice melts into open water, that absorbs more radiation, which causes more warming, which melts more ice, which reinforces and accelerates this issue. And we can see that's listed here, where warmer temperature melting ice, the surface is less reflective. Albedo is the term we use for how reflective something is. The surface is less reflective, its albedo is lower, that increases the absorbance of solar energy, which melts more ice, which becomes less reflective, etc. And so this issue can result in accelerated changes. Another positive feedback mechanism that's happening at the poles is the permafrost methane positive feedback loop. So again, as the poles, as cold areas warm, what happens is it melts permafrost. Permafrost are layers of soil that are generally permanently frozen. And so as the earth warms, that permafrost begins to melt. What happens is in that soil that's thawing out, there are microbes, there's organic matter, and they start to increase decomposition. And in those conditions, which are often anoxic, without oxygen, it releases methane, or if there is oxygen, releases carbon dioxide, which leads to more warming, which leads to more melting of permafrost, which results in more methane and carbon dioxide emissions. And again, we have this accelerating positive feedback loop that's happening at the poles. This animation that you're seeing playing in the lower left-hand corner also shows the melting of polar ice. And it shows historically what's happened, and it also is predicting out into the future the melting of that ice. Excuse me. And so that is part of that ice albedo effect, but it also has extreme impacts on polar wildlife. Lots of different species that live in these polar regions, they are adapted to life on a frozen area, on areas where there is sea ice. We can see some of that shown here. It shows a whole bunch of different species. Often these are specialists that have adapted over time to life in this ecosystem. And as the melting of the polar ice caps continues, it interferes with the lifestyle, with the survival capacity of all of these different organisms. Lots of organisms spend time on these ice platforms, foraging for food, and then moving on to land. And as that ice melts, then those organisms are left without a habitat they are well adapted for. And at the poles, so in other parts of the Earth, biomes are migrating towards the poles as the Earth warms. But at the poles, there's nowhere for those ecosystems to migrate. They are just disappearing. So when we talk about climate change and what humans are doing or trying to do, we talk about two concepts. We talk about mitigation and adaptation. And those mean two different things. So mitigation means trying to reduce the amount of warming that is happening. It's about reducing greenhouse gas emissions or increasing carbon sequestration in some way. And so when humans realized, when scientists understood that the Earth was warming at a very dangerous pace, started to come together under the direction of the UN and started to come up with agreements, treaties, protocols that could hopefully reduce those emissions. And we'll talk a little bit about that process. So in 1992, the UN Framework on Convention on Climate Change, it's called UNFCCC, was established in 1992. I actually remember this because I was an environmental studies major at University of Vermont during this time. We knew about climate change. I learned about climate change at that point. Scientists have known about the greenhouse effect for a century. But it was in the 1990s when countries started to realize we have to address this problem. And so the UNFCCC started bringing together countries of the United Nations to try to address this issue. The meetings that they have each year are called COPs. It means a conference of parties. There have been the 30th COP is happening in November of 2025. I believe it's happening in Brazil. The first COP was happened in 1995. That happened in Germany. And at these meetings, representatives from various countries come together, look at data about how the climate is changing, look at data about emissions, and try to come up with some ways of reducing emissions, of limiting climate change. So one of the first main agreements that happened was in 1997. This is called the Kyoto Protocol. It was an international treaty in which countries from around the world agreed to reduce their greenhouse gas emissions. And all of the countries that signed the Kyoto Protocol in 1997 agreed to cut their emissions to 5% below 1990 levels. That was sort of used as the baseline. And they were trying to reduce emissions 5% below 1990 levels by 2008 to 2012. Okay, and so that was a major treaty that many countries signed on to. Okay. And COP happens year after year, and there are sort of certain years in which there are major agreements or treaties or changes that happen, and those are the ones we're probably most familiar with. Another one is the Paris Agreement. The Paris Agreement took place at the COP in 2015, and this was, again, countries that were present at this meeting agreed to continue reducing their emissions at an accelerated level, okay, in order to reduce climate change. And so the Paris Accords, they're sometimes called the Paris Agreement, the Paris Treaty, in 2015. Countries voluntarily agreed to reduce emissions. And we can see the attempt was in the Paris agreements, scientists came to the conclusion that we were approaching dangerous, catastrophic levels of climate change. And so the countries agreed they wanted to try to keep the warming I think the language was significantly less than 2 degrees Celsius by 2100. Okay, and so countries tried to determine what they needed to do to achieve that goal, and then each country decided which policies they could implement to try to meet those goals. So to look at these graphs here, this shows a few different things. So we see the historic carbon emissions. That's the solid line. And then we see several scenarios that are shown here. Future scenarios. So if we look at this range, this line, is if there were no policies enacted at all. If no one were concerned about climate change, this is sort of the carbon emissions pathway that we would take. And in that case, this graph shows what the probabilities are. So if no policy was put into place at all anywhere, then we can see there is a large percentage, it's, I don't know, a little more than 50% chance warming will be greater than 4 degrees Celsius. And then another large chunk of that is 3 to 4 degrees Celsius, and maybe like a 5% chance that we could limit warming to 2 to 3 degrees Celsius. Okay. And just to give you some reference, 3 degrees Celsius is catastrophic. It would have major implications to the environment, to human society. It's really bad. Then there's other lines. This is if there was a low policy that did something, but not a lot to reduce carbon emissions. Here is the Paris Agreement. We can see under the Paris Agreement, as it was currently signed in 2015, here are the probabilities. There was, maybe about 7% probability we would keep warming at, between 1.5 and 2 degrees Celsius. A large percentage here, okay, maybe 50% more, that warming would be between 2 and 3 degrees Celsius, and a not insignificant chance that warming would still be 3 or above. And then there are also predictions about what would happen if the meetings that came after Paris, if we continued to accelerate our carbon reductions. And here's another scenario where if we increase our commitments to reduce carbon emissions, then we increase the chances that we could limit warming to 2 degrees or below and minimize chances of going to these extreme levels of climate change. So that's how these climate agreements work. And how will climate change impact human health? Well, there's a huge variety of ways. And we can't really get into all of the detail about each of them, but we can look at this graphic to show us some ideas. So you can relate some things to just the increase in temperature will lead to extreme heat, long-spanning heat waves. Heat waves can cause death and illness, and they have caused death and illness. And we'll watch a couple of videos that talk about some examples of that. So just the rise in temperature impacts human health in serious ways. Rising temperatures also result in severe weather. Okay? Storms, tropical storms, hurricanes, typhoons derive their energy from heat in the oceans. And as the oceans warm up, the strength of these storms is going to increase. Okay. Air pollution is another factor, that the carbon dioxide and other pollutants that come about when we burn fossil fuels can lead to cardiovascular disease, asthma, emphysema, etc. As the earth warms, vectors of disease such as mosquitoes and ticks and other vectors can expand their range and change their range, and that can result in diseases which are spread by these vectors expanding in their range and increasing in incidence as well. Increased carbon dioxide results in higher levels of pollen being produced by plants that can lead to higher levels of asthma and allergies, respiratory stress. Water quality due to warmer temperatures can impact things like algae blooms and waterborne illness. As agriculture changes, our food supply and where we get that food, how much food can be produced, can lead to malnutrition, can lead to epidemics of starvation and famine. And also, as sea levels rise, as climate becomes intolerable in certain parts of the world, that means people need to move. We call those sometimes climate refugees, people that are forced to leave their homes because of climate change. And that can lead to civil conflict, can lead to issues of mental health and forced migration from one place to another that can have serious societal impacts as well. So we mentioned climate change mitigation, but there's also the concept of adaptation. Adaptation is basically acknowledging that climate is changing, it has changed. So how can we adapt to that? What actions can we take to help us deal with these changes? This is happening right now. One example is in Miami. Downtown Miami is very close to sea level, and it is constantly flooding, okay, because sea level is rising. In Miami, they've had to elevate roads. They've had to install giant pumps to pump water out because streets were flooding at every high tide. They have already seen the impacts of climate change and rising sea level, and adaptation is how do they deal with that. This map shows areas, this is South Beach, that in Miami, that will be inundated with water as sea level rises. And we could see there's all sorts of impacts of climate change, as we already talked about. And so here on this table on the right are, well, what are some things that can be done to help humans adapt to these conditions? You know, how will we deal with the changes in agriculture? How will we deal with changes to human health and water quality, etc.? And so there are things that can be done, but it requires, investment, thought, planning in order to do this.